Hello guys, welcome to this video on Journey to Microservices. In this video, we will talk about Journey to Microservices. We will try to talk about how did we arrive to microservices. It's a vast topic and I will try my best to show the journey from web services to microservices. And before we proceed further, I would like to introduce myself. My name is Samir Bogeti. I have 12 years of experience in IT information technology. And the core technology areas which I have worked upon are Java and JTWE and frameworks like Spring, Spring Boot, Play, Spring Cloud, microservices architecture, AWS, Docker, and Kubernetes. Coming to personal hobbies, I really like reading books. Well, that's about me. Let's proceed further. Now, um, before we proceed further, it would be, very good to talk about something about web services. So, when we hear the term web services most often in our industry and in our day-to-day work environment, so what comes to the mind when we say that we are developing web services? So, if we have to give a generic definition, it is just a reusable service or reusable services rather, which are available across the internet or intranet. So the most easy way and the most convenient way to understand this would be like take for example if two services want to or two companies or two enterprises they want to interact with each other. Say take an example say for example say if I'm starting an e-commerce company, then I would like to collaborate with any of the courier providers like FedEx, DHL or Blue Dart to do the posting for the parcel dispatch, for the order dispatch services. So in this case, I can't really build the entire courier system in my particular application because that's not part of my business context. So web services and business contexts, these two terms are pretty much linked to each other. So essentially, with the usage of web services, we are trying to solve specific business concerns. So in this case, the business concern is to be an e-commerce company. That is basically to catalog products, to show products, to be able to sell products, and to be able to dispatch products. So for dispatching, it's not the concern of the e-commerce company. It's some other third-party provider which has all the infrastructure and which has all the other logistics sorted out, who are experts or who are professionals in that particular field. So often e-commerce companies collaborate with dispatchers like names like FedEx or Blue Dart or DHL to do the dispatch work for them. So in this case, when two entities, two business entities or two enterprises are talking to each other, so we say that they are talking through web services because ideally for an e-commerce company, the dispatcher service company will be a black box. So the company doesn't know. All it just knows is there is a contract between the two enterprises which they entertain and they respect. So it is something like I just send some particular data. So I exchange some data with company A, between company A and company B, and I need not know what are the internals of company B. All I just care about exchanging the data, sending them the request, and them expecting some sort of a response through which there is a communication which is being established, and we can also track interaction between these two systems. Typically example would be like, say for example, let's assume there is a system which is built on top of Java, and tomorrow if I want to integrate with a system or an application built on .NET, or if I want to go further and I want to integrate with mainframe system, then this kind of communication architecture is possible through web services. So coming further to specific web services, we have something called as SOAP-based web services. So SOAP, the acronym, it used to stand for Simple Object Access Protocol, but of late, SOAP is not an acronym anymore. But when it was new in the market, everyone was having, or they rather coined this particular term, Service Object Access, Simple Object Access Protocol. I'm sorry. So these are the backbones, or these are the initial web services mechanisms, or the method through which web services were being built. So coming to the details of SOAP-based web services, so these are a bit on the heavier side. They have a set of well-defined rules. Well-defined rules in the sense they have well-documented client, or they have well documented definition language. So for example, if I want to communicate with a SOAP based web service, then there is a specific mechanism, like we follow something called as a WSDL, through which we come to know what kind of services are being offered, and the message format, the format in which data will be exchanged between two systems or more than two systems. There is a specific format for that, which we call as SOAP message. So SOAP message, it contains something called as SOAP envelope, SOAP header, and SOAP body, which is a standard format. And SOAP kind of enforces us to follow this particular standard for standard communication and data exchange. And XML is the data exchange format in case of SOAP-based web services. It supports both synchronous and asynchronous modes. So synchronous being whenever you invoke a web service, you don't wait, you always expect some sort of a response or some sort of a operation, which is, you know, say if you are, a typical example would be if you are accessing a web service which talks to a database behind it. So that is a synchronous operation, because you are expecting that the data what you're sending to the web service will be persisted in the database and you'll get a response back immediately. Similarly, asynchronous modes, it's not synchronous, so it might be you are integrating with n number of different services through queues or through adapters, and there is no actual data persist, but you don't wait for a response to be generated immediately. So you just dump the data in the asynchronous web service and then don't expect a response back. So that is an asynchronous mode. And as I mentioned, service discovery and documentation is available through something called as WSDL, which stands for Web Services Description Language, based on which the consuming client needs to write the implementation. Say if I want to consume a particular SOAP web service, then I need to have the WSDL, based on which I can generate the client. I can send the requested payload or the required payload, and then expect some sort of a response which is governed through the WSDL. And as I said, messages need to be in a specific format, in the SOAP messaging format, like we have a SOAP envelope, we have a SOAP header, and a SOAP body. And the most important part being, communication is not restricted to HTTP or HTTPS alone. SOAP supports a lot of protocols apart from HTTP, say being CORBA, IIOP, RMI, UDDI, all those stuff. Yeah, no. The whole intent behind talking much about SOAP-based web services was, initially when I started my career way back in 2007, so SOAP was the hot property. Everyone was implementing SOAP-based web services, or there were systems which were being maintained and which were being built on SOAP-based web services. And gradually, if I fast forward 12 years, that is 2019, by the time we are recording this video, everywhere we just see that the whole industry or the whole paradigm shift is towards microservices. So I thought it would be beneficial if we spend some time talking about SOAP-based web services. So basically, how did all of this start? Moving forward, so this is a sample SOAP message. As I said, it contains something called as a SOAP envelope, in which we define the XML namespace and SOAP encoding style, and we have SOAP headers. SOAP headers are optional actually, but we can still pass in for some sort of security parameters or stuff like that. And we have something called as a SOAP body. So SOAP body contains the basic request in XML format, which will be taken care by the client based on the WSDL being generated, being used by the client. So the SOAP body will contain uh, the request or the response in which format the WSDL is governing. So this is a WSDL structure. So it contains something called as definitions, and it contains something called as types. So what kind of data types the web services is expecting. So what kind of message definition of data being communicated, like what kind of data is being communicated, and the type of operations and data format specifications which are defined as in this particular structure, which is a typical WSDL structure. Now, moving forward, so the whole process or the whole governance related to SOAP-based web services was governed through something called as SOA, which stands for Service-Oriented Architecture. Now, see, SOAP-based web services are basically APIs, or what we can say, those are the core business interfaces. And SOA is a way of governing those business APIs or business interfaces. It will be the separation of concerns here is that how do we orchestrate or how do we choreograph among services, how do we integrate the whole system, how do we integrate the whole architecture, and what tools or technologies or what kind of methodologies we will be using to govern the SOAP based web services. So before the advent of microservices, we had something called as SOA. Even SOA is prevalent now as well, as a lot of established enterprises have adopted SOA and they continue to do so, even if they are working on microservices onboarding and integration and development. Still, SOA is the heart for them. A typical example would be a core banking company or a core bank or a typical bank which whose enterprise was built around 20 years or 25 years back or more than that. So typically these enterprises are still running on SOA, and as I said, APIs. So APIs in this case are the SOAP based web services mostly, which are considered as business components. Moving forward, so this is a typical SOA enterprise, and this image I have taken from a site known as Simplicable. So this is a one-stop image which makes a lot of things clearer. So as you can see, we have a set of business processes, SOA services, components, applications, and data. And we have something called as enterprise service bus. And we have something called as quality of service, security, monitoring management. So as you can see in this particular image, we have set of well-defined business processes, which are the typical APIs in this particular case. So we take care of the service orchestration, we take care of the service choreography, and we have something called as SOA services. So basically, the whole choreography or the whole data exchange between services or between layers is happening through these services, and we have different components which are interacting with the backend applications or backend data. So in this case, the applications and data might be JMS queues, might be adapters, might be some sort of other storage mechanism where data is being stored primarily in an XML format or some sort of a database. which might perform further triggering, or which might be taken care for asynchronous processing. And then we have message exchange, message brokers, security, and versioning. So this is a typical SOA enterprise. How does typical SOA enterprise looks like, or used to look like, when development was going on mostly in SOA based systems? Moving forward, so coming to RESTful web services, which is a more familiar territory nowadays, as a lot of companies are moving towards RESTful web services development. So let's try to look at the brief history and what exactly are RESTful web services. So REST, it stands for representational state transfer. It's a term coined by Roy Fielding in the year 2000 as part of his PhD thesis. So Roy Fielding is also associated with the Apache HTTP server, and I think he was the one who kind of authored the HTTP protocol and all of the methods and all. So it's a term coined by Roy Fielding. So basically, RESTful architectures or RESTful web services are kind of an architectural style where, say, everything is considered as a HTTP resource. So everything is being treated as a data, or as an asset which is available across the web in the form of HTTP. So all the HTTP methods like get, put, post, delete, patch, all of the standard HTTP operations can be applied to the RESTful web services as well. And the data exchange mostly happens through JSON in this case, even though RESTful web services support XML and HTML as well, but JSON is the one which is being preferred mostly. These are very lightweight and portable when compared to SOAP, because essentially these are just HTTP resources being exchanged, or messages being exchanged in a very lightweight format as compared to XML. JSON is very lightweight and it takes very less amount of serialization and deserialization to process a JSON. So the network calls are not that much expensive and not time taking. And these are basically synchronous in design, and HTTP is the primary communication mechanism. We cannot have CORBA, IIOP, or RMI calls happening through RESTful web services. It just supports HTTP. So, and as the naming mentions, these are synchronous in design. That means any operation has to have a side effect. Like if I am requesting, or if I am doing a get operation, then my RESTful API, it gives information from a database or from some sort of a storage, and it just stops there. It's an idempotent operation. Similarly, if I am posting some data to a RESTful API, then I expect the data to be inserted or persisted in some sort of a storage, and I get a response back immediately. And responses are standard HTTP responses in this case, like the 200 series or 400 series or 500 series responses which we have for HTTP. Same gets applicable here as well. So these are synchronous in design, like whatever operation we do on the RESTful web services, it'll have some consequence, like some data being persisted somewhere, or some resource being exposed, or some resources being retrieved. So that's the primary introduction to RESTful web services. As the name says, it's an architectural style, but not a particular protocol like SOAP. And it does not have too many standards, like it doesn't enforce the developers to adopt to something called as WSDL, or it doesn't enforce to follow some sort of message exchange format like SOAP messages. It doesn't have any sort of envelope, body, or header. It is just plain JSON messages. Whatever data you can expose as HTTP, those are very lightweight, and it doesn't kind of enforce you to form a message structure, stuff like. And yeah, so that's more on RESTful web services. So going ahead, these are the advantages of REST over SOAP. So it's very easy to develop and implement as it is just HTTP and everything is a HTTP resource. So it's very easy to develop and implement, and it's very easy to expose REST services as well because it will be just a HTTP URI or the standard HTTP URI which gets exposed for consumers to consume. It has got very short time to market. So when I say it has got a very short time to market, that means to develop or to make my API available to the consumers, it takes very less time when compared to SOAP services because basically I'm just exposing my HTTP resources as a service. So it doesn't take much time when compared to SOAP services, where in case of SOAP web services, it has got a lot of infrastructure concerns. There are a lot of components which we need to view together. There are a lot of standards which we need to follow. But that's not the case with RESTful web services. So it has got a very short time to market. Typically, it'll just take if the planning and the analysis, the estimates are done properly, then you can expose a web service or a RESTful API within a week or 10 days, and the consumers will be able to consume the API or do the message exchanging between them. Development and testing time is minimal, so this is very much related to the previous point that it has got a very short time to market. It gels perfectly well with agile methodology, so we can with proper planning and with proper estimations, as I said, we can deliver an entire API within a sprint, or we can deliver the major work and then take ahead the tech debt and then try to stabilize the API. And one more very good thing with RESTful web services is, say, if something is not working with this particular service, or say what you started with and what you ended up with, it's not in sync, then you can just simply discard it and try to write it over again. Yes, and the most one of the most important or favorite points will be that same functionality can be developed in various technologies and programming languages, thus making it possible to leverage polyglot programming. So, as it is just a HTTP resource, I can develop my RESTful APIs using Java or .NET or Ruby on Rails, Node.js, Python. So there is a huge list of programming languages which is available. Even Go we can use Scala as well. So there are a lot of options when coming to developing RESTful web services. As so it promotes a polyglot environment, so we don't stick to a particular technology, or we don't particularly stick to a particular framework, because all the things which we care is just the exchange should be in the form of HTTP and JSON. And it also enables SaaS model. So it is something called software as a service. Say for example, if I want to sell my API, or if I want to um, have a lot of other consumers, if I want a lot of other consumers to use my API. Say, for example, as I mentioned earlier in the presentation, if I have a dispatcher company and I can define a contract, or I can define a security API key mechanism to be made available for the clients. And so essentially, my software, I'm exposing it as a service. So this particular term, SaaS, is kind of the seed for microservices, so which essentially became microservices going ahead. So these are the advantages of REST over SOAP. So basically, all the points that I have discussed till now, it's being like a typical journey, like how we started from SOAP-based web services. We followed the SOA style of deployment, development, and other cross-cutting concerns. And then we had something called as RESTful web services, which made the development of web services really easy. The deployment, the development times came down drastically when compared to SOAP. And then essentially which laid the foundation for something called as SaaS, and which in turn laid the foundation for microservices. So that was the whole intent of going over the web services part, the SOAP-based web services part, and the RESTful web services part. Now let's try to explore further. So these are the disadvantages of REST. It is primarily HTTP driven. It doesn't have support for other protocols like CORBA, IIOP, UDDI. So those things are not supported here. It has got no standards, unlike SOAP. There are no WSDLs, there are no SOAP messages, there is no SOAP message structure, which sometimes makes it difficult for the clients. If there is no proper documentation, then it's a real nightmare to consume the APIs, and when we don't know what kind of data or payload we have to pass. And if not planned and designed properly, it can be a nightmare to manage. Like if you are not sure, or if you have not planned properly, like what kind of data, what kind of information you will be exposing through HTTP, and you end up with changing your payloads, or the type of payloads you accept, the type of payloads you send back frequently, then it will be a nightmare and it won't definitely meet the business goal. And this is not suitable for asynchronous systems where we cannot really dump in the messages or the JSON files or the data to any asynchronous data sources. So like we can't dump it to JMS queues, or we can't really dump it to any sort of adapters. So there has to be some sort of a intermediary storage or intermediary persistence. From there on, it will be further processed, it will be taken up by some other process. So there is a lot of chaining, and we can't just straightforwardly design it for asynchronous processing. These are disadvantages of REST. So this is a small comparison chart which I have prepared. So it's as the left side says, SOAP is a protocol, the REST is an architectural style. SOAP cannot make use of REST, so I cannot invoke a RESTful API from a SOAP service. But whereas REST can make use of SOAP, because essentially all it cares about the payload, what we are going to send, and the data, what we are going to receive. So in SOAP, the WSDL file provides the client with the necessary information which can be used to understand what services the web service can offer. Similarly, REST uses uniform service locators, URIs, to access the resources. Amount of data transfer using SOAP is generally a lot. So this point means there is a huge amount of messages being exchanged between SOAP-based web services, and the size of each message is huge, which makes it really difficult and memory intensive to marshal, unmarshal the messages. Serialize, deserialization is a huge headache in case of SOAP web services. Not much with REST, because as it is mostly JSON driven, even though it supports XML, HTTP, HTML as well, but REST is primarily JSON driven. The messages are very lightweight, and serialization, deserialization, marshalling, unmarshalling is not much of a pain point. So, so essentially, SOAP is all about XML, but whereas REST supports various exchange formats like HTML, XML, JSON. So these are the primary differences between SOAP and REST. And as we have covered the journey so far, so we had the concept of web services, and then we graduated something into SOAP-based web services, and then we encountered something called as SOA, and from there on we went into RESTful web services, and then we tried to compare both of the API development techniques, which have a lot of differences, few similarities as well. Essentially, it's all about data exchange. When we say both of these are the style of developing web services, so it's all about exchanging data between systems, and REST really makes it easier to exchange data in form of JSON, and it really doesn't care about any sort of standards or any sort of documentation. All it cares about is just a URI. It should be able to call, it should be able to make some HTTP operations. So it became simple with the advent of REST to design your APIs, and the most important part being the time to market, the time to shell out, or the time to expose your resource or web service to the market. It became drastically less when compared to SOAP. And then we also had a look at something called as SaaS. software as a service, where a lot of organizations started selling their APIs through RESTful web services. A typical example would be Amazon or Walmart. They sell a lot of their APIs for their catalog search and offer search and all of that stuff, which we won't be looking at in this particular presentation. So let's move ahead. Now, uh, so around this particular time when we had RESTful web services being adopted majorly by huge organizations or startups, companies like Netflix, companies like Facebook, when around 10 years back or the last 8 years back, when RESTful services were being embraced more and more, and it came to a point something called as SaaS, and from therein a term was coined by name microservices. So as the technical innovation speed started to increase, in the sense when we had this sort of an information technology revolution where a lot of smartphones, a lot of smart devices started getting developed, and the organizations were forced to rethink about their business strategy, because it was no more like only you that PCs were not the only clients, or laptops were not the only clients of web pages. So you had a lot of apps coming in, Android, iOS, the APKs, the iOS systems, they got matured a lot, and then there was the cloud services boom started by AWS, companies like AWS, and which it gave rise to a particular technology revolution where everyone started to say that they are on the verge of digitizing their business. So when I say digitizing and taking part in digital transformation, it's like with the advent of smartphones or with the advent of wearable devices or smart devices, we can talk, or we can do mobile marketing, we can do e-commerce through apps, we can do payments, bill payments, we can do banking through applications installed on the mobile phone rather than logging on to the website on the PC. So it became very easy, and similarly, as organizations, they started to realize that this has got a huge potential, and they really wanted the time to market to be reduced drastically. So in this case, the advent of microservices started. So in general, coming to the definition and all, there is no standard definition for that. So every organization or every person has got its own definition, but the most widely accepted definition would be it's a set of micro components interweaved together, which are extremely fault tolerant, can discover each other, and are highly scalable, and they comply to something called as CNCF standards, that is Cloud Native Computing Foundation standards. We will have a look at what CNCF is as well. And the emergence of infrastructure revolutions like Docker, Kubernetes, it really made things easy. So you don't have enterprises or organizations, they need not spend more money or more effort in establishing their infrastructure. With the help of virtualization and revolutionary technologies like Docker, Kubernetes, it really became very easy to ship their applications, to port their applications with the help of Docker images and orchestration and choreography through Kubernetes. And one of the general misconception about microservices are all REST. So this is not correct. Even SOAP-based services can be microservices. It promotes DevOps culture. It brought in something called as DevOps culture. So the tools or the technologies which we mentioned, like Docker, Kubernetes, it really made it easy for organizations to ship out or port out their applications to reusable components like Docker images without having any huge infrastructure setups. So this led to something called as innovation in DevOps. So DevOps, it's something like development and operations combined together. This led to so the microservice revolution, or this led to something called as DevOps culture as well. So wherein there is no difference or there is no differentiation between developer and operations team. So initially when work was being done as part of SOAP web services, the development team was different, the operations team were different. So once you have developed your components and they have been deployed, maintaining them and operating them was not the concern or not the headache of developers anymore. It was all the operation guys who took care of the services which for which the development is done and they are in maintenance stage. But with the advent of DevOps, that line has been diminished. So DevOps, it just says that if you have built that particular service, then you own it. You are the owner. You're operational. You're responsible for the operations of that particular service. So the focus is more on having stable and robust CI/CD tools and processes. So with DevOps came a lot of CI/CD practices like Docker, Jenkins, Bamboo, Travis CI, and then we have something called as Vagrant, Chef. A lot of things came into picture. And with microservices, there is no single point of failure. So when we say there is no single point of failure, say for example, if I have an application, if I have a typical web application, and if one of the multi-layered components is faulty and there is a failure, then the whole application goes down as part of as because there is a failure in one of the components, but not in the entire application. So the entire application has to bear the brunt for that. And it makes full use of polyglot environment, as I mentioned in one of the previous slides. The REST style of development doesn't restrict you to develop APIs in other programming languages, or it doesn't stop you from exploring other opportunities like say you can develop HTTP resources as part of Ruby on Rails or Java, Scala, Kotlin, Go. A lot of languages are available nowadays through which we can develop or scale our APIs quickly. Now, this is one of the more important topics which I wanted to emphasize on. So, microservices, these can be applicable for both monolithic web applications and enterprise APIs as well. So, we will talk on this point more elaborately in the coming slides. So, this is the particular CNCF landscape. Like in the previous slide, I said that the microservices, they are compliant to CNCF set of tools and libraries and standards. So this is the whole CNCF landscape. So, there are a huge set of technologies which have been divided into specific concerns like scheduling, orchestration, databases, streaming and messaging, and then platforms, what kind of API gateways. So basically, with microservices, the focus is on making the applications cloud native, and these are the technologies, tools which help the microservices or the APIs to be compliant with cloud nativeness. So it's a huge picture. You can This is available on the internet as well. If you type CNCF landscape, then you can see this picture, and there are a huge set of technologies. Something like on this board you can find Kubernetes, Docker, Spark, Kafka, a lot of technologies. Many of the things even I have not worked upon, even say very I can relate with very few or very few tools like etcd, Netflix, Kubernetes, Minikube, Rancher, Docker, all this stuff. So it's a huge list, and so this is the way forward if you want to adopt to microservices style. So you need to be adhering to this particular landscape. So it's a very interesting landscape. I recommend that everyone go through this and try to understand what are the tools, technologies. Coming to a sample use case of microservices. But before we proceed further, so till now we have seen like how the typical enterprise development graduated from web services, the idea of web services, SOAP-based services, microservices, RESTful-based services, and how eventually we came to microservices. Essentially, with the advent of RESTful web services and the changing technology landscape, it became very crucial for enterprises to reduce their time to market. So it became really important for them to stay in the race to digitize their enterprise. So when we say digitize, so adopting the CNCF technologies, making their applications more scalable, highly available, more robust, and less clumsy in terms of message exchanges and very lightweight. So all of these things they led to microservices, and here we will try to explore the sample use case of microservice. Now let's consider the multi-tiered and multi-layered monolithic web applications. So in case of Java, if you have to develop a web application, so in the old days, we always had to port out a WAR file. We had to manually deploy it on either Tomcat or any of the application server like WebLogic, WebSphere, or JBoss. So it used to have multi layers and multi tiers. So a typical HTTP request flow would be like, uh, say we have a web browser, which is the client in this case. It interacted with something called as a web application, which was the WAR file being deployed manually or through scripts on physical servers like Tomcat or any of the application servers. And we had different layers, like we had controller, we had service, we had DAO, that is data access object, which in turn used to interact with a database. And then say if I did any CRUD operations using this particular application, so it used to follow a single war file structure where all of the code has been pumped into one artifact and there is no loose coupling among the components. So all of this logic, it resides in the same deployable artifact. Now coming to the redesign by using microservices. So if we have to kind of decouple these applications or decouple this application, say as I had mentioned, if there is some problem in the DAO layer, say if it is not able to communicate with the database, then the entire web application goes down for me. So the web browser will always receive an error message even because of failure in one layer, which basically we don't want that to happen, right? Because of one single failure, we don't want the whole application to go down, which was one of the main pain points of monolithic applications. One failure and the whole application used to go down, and which is a bad scalability concern as well. So the same business problem, if I had to refactor and redo using a microservice based approach, it would typically look something like this, something similar to like this. So on the left hand side, we can see a lot of web clients, like we have a mobile client, we have a web client, and anything that supports HTTP calls, it passes through something called as API gateway. It has a router component, which essentially which is a HTTP API or a RESTful API, and which is a generic component. So tomorrow, if I want to add one more service component, then I just can configure it in the router component and calls will be delegated to the other service. So in this case, I can just delegate it or extract the common routing logic to a router, and then we can invoke the service, which is a separate HTTP service, and we can also integrate that with the data store component, which is a separate RESTful service or a HTTP service, and then which in turn interacts with the database. So the advantage what we get in this particular case is if there is failure in any one of the component, Say if we have failure in the data store component, then using fault tolerance techniques and high availability techniques, we can still say that the application is up, but it becomes easy for us to identify like which particular component is down. And because of that particular data store component being faulty or being down, the entire application is not down, unlike the case in case of a monolithic application. So this is a more graceful and a more better handling. Say if I and moreover it promotes extreme loose coupling. Say for example, tomorrow I want to remove this particular service component, then I just need to take care of the URIs, that the URIs should be same, and internal technology it can change. So tomorrow, if I develop a microservice in Java and I find that it's very clumsy and it's not that much cool, I want to do it in Go or I want to do it in Ruby on Rails, then I can just simply remove the service component and do it in Go or any other programming language, and I can just replace it because essentially the contract is just with the URIs and not with the underlying technology. So it is all essentially black box for the router and data store. So these kind of advantages we get if we adopt a microservice architecture. As you can see, typical microservices enterprise will look like an AP like this, where we have something a component called as API gateway. So API gateway, it is basically one layer before your actual micro components or microservices, through which the entire routing or the entire routing rules or HTTP rules or the security rules are governed. And coming back, so when I said in the previous slide, like microservices architecture is applicable to both monolithic applications and enterprise applications. So this is a typical enterprise call being happening. So we can have a set of microservices which are interacting with each other, which are able to discover each other and are able to communicate with each other. So these are all very small, very granular systems being combined together to form a single microservice. And then these are all talking to each other. So this way we can adopt microservices in enterprise integration as well. But typically, um, it's a debatable topic. Say a lot of people believe that SOA is far better, or microservices are a better version of SOA. So SOA done correctly leads to microservices. So all of these things are very debatable, and different developers and different organizations have very contrasting views on microservices. So till now, as we have seen, we started with the idea of a web service, and then we gradually came into microservices. So eventually, you can see that the primary driving factor behind evolution of microservices architecture is pressure on organizations to innovate more in terms of business capabilities, to provide more services pertaining to mobile, pertaining to any wearable device, or to do some sort of businesses using push pull notifications, or to basically enable people to leverage the full power of internet. So that is the main driving force behind adopting the microservices architecture. And as I said, so there are a lot of technologies which we can leverage. And yep, and what kind of tools and what kind of processes or uh, what kind of technologies are available to adapt. So basically, the idea is that microservices should be cloud native. That means I should be able to easily deploy them over the cloud, and then it should be able to work. So that's all I wanted to cover as part of this small presentation, even though I know that it's a very vast topic and it's really, really almost impossible to cover all of the topics in this very particular short time or as part of one single video. But I tried to highlight the whole journey, like how all of this started and how we reached to microservices. I will try to post few more videos, like how what is the way forward, or I will also try to post specific examples, like I will try to emulate a business challenge. So that's about me. Thank you very much.